So yeah, you have that packet and it looks like it'll be updated and available online for your reference in the future. Next topic, agenda item number 11. We're going to be discussing water quality trends in Southwest Florida. And this will be presented by Miles Medina, Eco Scientific. And Miles is joining us online. The purpose is to brief the Committee on Water Quality and other ecological trends in the CHNEP estuaries from 2000 to 2021, using data from the Coastal Charlotte Harbor Monitoring Network, the Water Management Districts, and the Florida DEP Aquatic Preserves. This relates to the water quality improvement actions 1.2 and 1.3, assessing and reporting trends in water quality, and assisting with consistent collection of technically sound long-term water quality data. All right, take it away, Miles. Thank you.
All right, hi everybody. Can you hear me okay?
Yes, we can.
All right, great. How long do I have? About 30 minutes?
Yes. Yep.
Okay, great. All right, so yeah, thanks for inviting me. I'm presenting virtually today, but I'll be in person at the policy committee meeting in a couple weeks. And if you've attended these meetings before, you've seen me talk about this work. This started back in 2022 while I was a research scientist at the University of Florida. In late 23, I left and established my own small research and consulting practice called Eco Scientific, and got this over the finish line just through a sort of labor of love through last year. And we got this work published in Estuaries and Coasts in January of this year. So the study period here is 2000 through 2021. So this provides a more than 20-year sort of history of water quality and eutrophication indicators related to seagrass and macroalgae in the system. Of course, 2021 was 3 or 4 years ago. So the information is due for an update sometime soon, and we got some grant proposals in to try to get to that later this year or next year. But anyway, this will give us a nice sort of overview of how water quality and seagrass and other things have changed over the last 20 years or so in the system. I want to acknowledge my co-authors listed on here from various organizations, including CHNEP, Charlotte County, Southwest Florida Water Management District, UF, Sarasota Bay Estuary Program, and Tampa Bay Estuary Program. All right, let's move on to the next slide. Okay, so just a brief overview. This should be pretty familiar. The CCHMN, or Coastal Charlotte Harbor Monitoring Network, has been monitoring coastal water quality throughout the greater Charlotte Harbor system since the early 2000s. The way the monitoring is conducted is according to this stratified sampling design, where we've got 13 different monitoring strata or areas as shown on the map. So this includes Lemon Bay, Charlotte Harbor proper, the river estuaries, of course, piece of Mayaca. And then down south, we have the Caloosahatchee River estuary and other nearby strata, Balanchine Pass, Pine Island Sound, all the way down to Estero Bay. Within each of these areas, or the polygons on the map, folks will go out and collect 5 samples from random locations within each of those 13 areas. And the random locations of that sampling gives us a sort of representative picture of what's going on throughout that area. This data set has been remarkably consistent over time, so it gives us a nice, really good view of what's been going on sort of month by month within each of these areas. The reason for these delineations, the way that the system is kind of carved out the way it is these different areas are considered relatively homogeneous in terms of habitat and water quality. So in this presentation, I'll be talking a lot about changes in water quality over time within each of these areas. So we're going to dive into each of these areas. We'll probably have to go, pretty quickly because there's 13 different areas. And then we'll also emphasize conditions over the last 5 years of the study period, which is 2017 through 2021. So we'll be looking at sort of long-term, 2000s through 2021, with an emphasis on those last 5 years. All right, next slide. Okay, so just briefly, I want to give a little bit of an intuition for how the trend analysis works because it's a little bit different than what you may have seen before with water quality trend analysis. So typically when folks do water quality trends, if you have a 20-year period, you end up with sort of one answer. Have concentrations of, let's say, nitrogen gone up or gone down or remained relatively stable. But of course, in the course of 20 years, a lot of things can change. You might have some periods where concentrations increased and then periods where they decreased or stabilized. And so we wanted to take a more nuanced view. And so we used this method based on GAMs or generalized additive models, which is a very flexible kind of regression. And in the end, it gives us a more detailed sort of view over time of how conditions have changed. And the picture at the top left there, I believe this is annual average concentration of the total nitrogen in, I think that looks like the Tidal Peace River. You can see how those changes occur. Like there's, some changes in direction, maybe some decreases and then some stability and then some increases. Key to understanding the results is that we evaluated trends on a sliding 5-year window. So what you see on the right of that plot is the sort of gray line indicating during those last 5 years, there was no real trend. That's 2017 through 2021. And you can imagine sliding that window back 1 year at a time. So we start, there on the later end, 2017 to 2021. If you slide back 1 year, then you're talking 2016 to 2020, 2015 to 2019, and so on, all the way back to the beginning, 2020 through, 2000 through 2004, right? So we're looking at 5 years at a time on a sliding window. And that's going to allow us to sort of track these changes in direction and stuff that occur throughout that 22-year period. And then the final component of the trend analysis is anchoring the trend results to some kind of absolute threshold, because if for example nitrogen concentrations are increasing, you see an upward trend, that may or may not necessarily be a cause for concern. If concentrations are very low and 5 years later they went up, but they're still very low, so you had an uptrend, but you're still in absolute terms, quite low, maybe that's not so alarming. But if you started off at a very high concentration and then 5 years later you increased to an even higher concentration, that would be a higher priority sort of situation. So we adopted thresholds based on the estuary specific criteria in Florida statute. So these are basically regulatory criteria. This analysis isn't a regulatory assessment because the criteria, the way of doing regulatory assessment is a bit more complicated than just comparing two numbers. But we took the numbers that are used in regulatory assessments and adapted them for our analysis here. As you can see, the numbers for each of the three things we're going to talk about, nitrogen, phosphorus, and chlorophyll, vary across different parts of the system, which makes sense. And it's worth pointing out that, we didn't dive into what, the appropriateness of these numbers. I think folks, rightfully debate, if these numbers are still right numbers, if they're too high or too low, that's a debate that's always worth sort of having and updating. But we just took the numbers as they are. We didn't dive into, if these are the right numbers or not. We just took the regulatory criteria as given. So this gives us a sort of relative, this trend analysis overall gives us a sort of relative view of how have things changed, and then we anchor that, uptrends and downtrends and so on, relative to these absolute thresholds. All right, next slide. Okay, so for each of the 13 areas, we're going to have 2 slides. So I'm going to spend a little more time on the first 2 slides, which we're going to go from north to south. So we're going to start at Upper Lemon Bay. I'll spend a little more time on these just to sort of explain what we're looking at here, and then we'll go a little more quickly through subsequent areas. And each pair of slides is going to follow the same format. So for Upper Lemon Bay, starting on the left side, these are the water quality trend results. So at the top, we've got total nitrogen. In the middle, we have total phosphorus, and at the bottom, we have chlorophyll. Now, what these plots are showing inside the plot, those red, white, and blue dots, are the results of the 5-year trend analysis. Remember, I said that we evaluated 5-year trends on a sliding 5-year window. So let's start by looking at actually the bottom plot, chlorophyll, because it's got all the colors in it. Inside the plot there, you see, for example, that first dot is in the 2004 position. That means that it's representing the 5-year period 2000 through 2004. Okay, now that dot is white and it overlaps 0. So what that means is that the trend was flat. Okay, chlorophyll conditions between 2000 and 2004 in terms of annual averages didn't show a statistically significant trend. So conditions were pretty much stable in that 5-year period. And then each subsequent dot represents, sliding that 5-year window over 1 year at a time. So the first blue dot there is, it's below 0, it's blue. So that means it's a negative or a downward trend representing the period 2002 through 2006, right? Because that blue dot is in the 2006 position. And then a few years later, starting in 2010, so this is representing 2006 through 2010, we have a red dot indicating the first upward trend. Okay, so we see some changes in trend direction from white to blue to white to red and so on. In the latter part of the record, we've got a couple of blue dots indicating some 5-year periods with downward trends. Now, along the top of this plot, you see those squares that are either white, gray, or black. And what those tell us is whether we are below, near, or above the chlorophyll threshold for upper Lemon Bay, which is marked there at 8.9 micrograms per liter. And so, the way to sort of read this is to consider the dots inside and the squares above sort of at the same time. For example, you see those 4 dots in the 2010s indicating upward trends for 4 consecutive 5-year periods. And that culminated in an exceedance of the threshold with that final black dot there. Okay, so you can see, this is kind of a different way to visualize how the trends have evolved, but it kind of summarizes all of the results, how those 5-year trends have changed over time and sort of where we ended up each year relative to the threshold. All right, so for nitrogen, we see, mostly we've been sort of stable, couple upward trends, and we've had some intermittent exceedances more recently, as indicated by those black dots toward the right. And most recently, we've been near the threshold. Total phosphorus, we've had some ups and downs in the trends, but for the most part, we've been below the threshold, as indicated by those white squares. And we already went over chlorophyll. So chlorophyll also ends up being sort of near or most recently below the threshold. And this is a sort of pattern we're going to see kind of throughout the system. Nitrogen is going to be, in many cases, trending upward, elevated. Phosphorus and chlorophyll, the trends might vary, but we're often going to be sort of below thresholds, typically. Okay, now on the right-hand side, at the top, we see these green bars. This indicates seagrass acreage, according to SwiftMud's aerial seagrass mapping effort, and this goes through 2022. And this represents all of Lemon Bay, not just Upper Lemon Bay. So we're going to see the same for Lower Lemon Bay in terms of the seagrass. But this is a pretty typical kind of pattern where we see some stability or increase into the late 2010s, and then following Hurricane Irma in 2017, we see a historic decline in seagrass. And then finally at the bottom, macroalgae. In this case, we see basically some pretty stable sort of dynamics in terms of drift macroalgae. In the paper, we actually used a different data set for macroalgae. We looked at transect data from the aquatic preserves. But overall, what we're seeing is some evidence, some indications that macroalgae seems to be proliferating and sort of increasing in several parts of the system. I guess I want to take a moment to distinguish macroalgae that we see on the right and chlorophyll that we see on the left for anyone who's not familiar. So the reason we measure chlorophyll in water quality samples is it's a proxy for microscopic algae, phytoplankton that are floating around in the water. Chlorophyll is a relatively easy thing to measure. So you can take a sample bottle, run it to the lab, and get a measure of chlorophyll as a proxy for those microscopic algae. Drift algae, on the other hand, are macroscopic algae, larger kind of algae that can also become a problem in ecosystems. Phytoplankton, both types of algae are sort of natural and belong in the system, but like too many weeds in a garden, if you have too much, it can indicate a problem. Okay, so that's the first slide in the pair. The second slide is emphasizing, short term, meaning 2017 to 2021, the most recent 5 years of the study period. And here, what we're looking at for Upper Lemon Bay is the nitrogen trends. In this case, we have a dot, meaning there was no trend up or down in that 2017 to 21 period. The pink indicates that we ended up near the threshold in 2021. And then for phosphorus and chlorophyll, the shapes are white, meaning that we were below the threshold. For phosphorus, there was no trend. For chlorophyll, it was a downtrend. It's worth pointing out that in many parts of the system, especially the north, 2021 was kind of an anomalous year. The average concentrations of nitrogen were relatively low compared to prior years up through 2020. And so 2021 gives a maybe like too optimistic view of what was going on in the system. I don't know exactly the reason why nitrogen concentrations were lower in 21, but when we look at the most recent period, it is a little bit different than what we see in the previous, window of 2016 through 2020, where there were typically uptrends in nitrogen. Okay, so those are the two slides for Upper Lemon Bay. Now we're going to go a little more quickly through the rest of the areas. So Lower Lemon Bay, for nitrogen, we see most recently in the 2010s some increases with those red dots that bring us sometimes into above the threshold territory with the black squares above the plot there. Phosphorus showed some changes in direction throughout the study period, but we end up pretty consistently below the threshold throughout most of the 2010s and through 2021. And then chlorophyll, we sort of go back and forth between being below or near the threshold, most recently below the threshold in 2021, with very few changes in trend direction. Seagrass and macroalgae data on this slide are the same as on the previous slide, so I'll skip that for now. On the next slide, we see a summary of conditions for Lower Lemon Bay, pretty similar to what we saw for Upper Lemon Bay. We're near the threshold with no trend in the period ending 2021, and we're below the threshold for phosphorus and chlorophyll. All right, now moving on to, let's see, what do we have next? Titled Peace River. Okay, so this is a good one. This is pretty representative of conditions throughout the northern sort of Charlotte Harbor proper parts of the system. So we see an early period of sort of stability in nitrogen concentrations. And then throughout the 2010s, we see pretty consistent uptrends, right? Now, the thing to remember here is that even though the first dot appears in that 2016 position, that actually represents an uptrend between 2012 and 2016, a 5-year period. So we're talking about, nearly a decade of consistent increase in nitrogen concentrations in the tidal Peace River that ultimately culminated in above threshold status in 2018, 19, and 20. And like I said, 2021 was sort of an anomalous year with lower concentrations than before. So in 2021, we ended up below the or near the threshold once again. For total phosphorus, we see mostly stability, a couple downtrends, and we're mostly below the threshold most years. And chlorophyll A, we're typically near or below the threshold. Okay, seagrass acreage increased leading up to Hurricane Irma and then decreased as in other parts of the system. And with drift macroalgae, you see some changes there over time with some possible increases in the last couple of years. Next slide shows short-term results for tidal Peace River. Similar to what we saw in Lemon Bay, near the threshold for nitrogen, no trend in that final 5-year period. And for phosphorus and chlorophyll, we are below threshold. Okay, next slide should be tidal Mayaca River. Similar to Peace, we see uptrends throughout much of the 2010s, brings us above the threshold, and then 2021 was sort of a low year, so we end up, uh, um, in terms of nitrogen, we end up near the threshold. Again, phosphorus and chlorophyll show a few trends, but we're mostly below the threshold. Seagrass losses, again, after Hurricane Irma, and um, some indications of increase in drift macroalgae in the latter years of that record. All right, next slide. Okay, similar story here. Pink dots for nitrogen, white, maybe different shapes, but ultimately below the threshold for phosphorus and chlorophyll in the Mayaca River. All right, next slide. Now we're getting to the west wall, Charlotte Harbor. Okay, and again, this is going to sort of mirror, what's going on in the rivers, right? I mean, a lot of the water that comes in to Charlotte Harbor proper comes from these two rivers. So we see these upward trends in the 2010s for nitrogen, and that brings us into um, above the threshold territory all the way through 2021. So 2021 was not really a low year here at the West Wall. Total phosphorus, we see a couple uptrends in the 2010s, and that brings us sort of near the threshold. And then chlorophyll A, we see some uptrends in the early 2010s, brings us above the threshold, but then things sort of decrease enough to bring us down into near threshold territory later in the record. West Wall, of course, we saw some decreases in seagrass in the green bar plot there, and some increases in macroalgae. And on the next slide, we see the summary for 2017 to 2021. Here we are in above threshold territory for nitrogen, even though there was no trend for the 2017 to 2021 period. And we ended up in near threshold territory for phosphorus and chlorophyll. All right, next up is East Wall. So here, similar story, uptrends during the 2010s for nitrogen. 2021 was a relatively low year, again, like we saw in the Peace River. So we went from several years of exceeding the threshold to near the threshold. Total phosphorus, despite an uptrend in the late 2010s, we remained below the threshold. And chlorophyll A, we're near or below the threshold with some late downward trends. Seagrass acreage, again, decreased, and macroalgae appears to have shown some increase. All right, next slide. Okay, so here, 2017 to 2021, we're near the threshold for nitrogen, no trends, and phosphorus and chlorophyll below the threshold in 2021. All right, now Lower Charlotte Harbor. Here, this region gets a bit more tidal exchange, direct connection to the Gulf. So the results are a little bit different. We see some uptrends sprinkled in the 2010 to 2020 period. A couple of times for nitrogen, of course, we're in 2018 and 2020, we see exceedances of the threshold. And in 2021, we end up near the threshold. Phosphorus, despite quite a number of significant trends, initially down and then up into the 2010s, we remain below the threshold. And similarly for chlorophyll, despite a couple of trends, we remain below the threshold. Again, Lower Charlotte Harbor exhibited some seagrass losses and some possible increases in drift macroalgae. All right, next slide shows 2017 to 2021 period. So we've seen in a lot of places, we're near the threshold with no trend for nitrogen and below the threshold for phosphorus and chlorophyll. All right, next slide. KPAs. Okay, some increases in nitrogen in the 2010s, bringing us near or above the threshold, below the threshold for phosphorus, and typically near the threshold for chlorophyll with a late downtrend that brought us below the threshold most recently. Some losses of seagrass apparent here and pretty stable drift macroalgae abundance around KPAs, although I believe in the paper we with based on the transect data, I think we observed some increases following Hurricane Irma. All right, next slide. Similar story here, pink dots for nitrogen, white symbols for phosphorus and chlorophyll. All right, moving on. Now we're getting into the southern segment. So Tidal Caloosahatchee, this showed some markedly different behavior in terms of nitrogen. You'll notice that nitrogen and phosphorus are full of black squares. So we are above the threshold for both of these nutrients in the Caloosahatchee River consistently throughout this 22-year period, excuse me. And that's partly due to the fact that the TMDL concentrations for nitrogen and phosphorus are markedly lower here compared to, for example, the Peace River, where the nitrogen threshold is, I believe, 1.08 milligrams per liter, and the TP threshold is something like 0.5 milligrams per liter. So we're, the regulations are a bit more aggressive for Caloosahatchee, harder to attain. Now, the behavior for nitrogen is interestingly different here in the Caloosahatchee. We see quite a bit of variability in the early record through about 2014 or so, and then there's a sort of stability that emerges during the last 7 or 8 years of the record. And we don't know exactly what explains that difference. It might have something to do with the difference in hydrological management. Of course, Caloosahatchee is actively managed by hydrologic flow control structures and different sort of management regimes that the Army Corps has adopted. So that might have something to do with it. It might have something to do with biogeochemistry in this area. But this is quite different than what we see in the northern parts of the system, where there tended to be sort of increases throughout the 2010s in terms of nitrogen concentrations. Again, phosphorus trends have gone up and down over the years, but always exceeding the threshold in terms of annual average. And chlorophyll most recently went up near the threshold and then came down below the threshold below the threshold in 2021. Seagrass acreage really took a hit between 2014 and 2021, which is when we have data for from South Florida Water Management District's seagrass maps for this area. And it's hard to say with the algae because we don't have as much data here, but potential increase in macroalgae coverage or abundance. All right, next slide. Okay, so yeah, a lot of red here, right? Exceedances for nitrogen and phosphorus, even though for phosphorus we saw a downtrend between 2017 and 2021, and yet below the threshold for chlorophyll, which again is pretty common throughout the system. All right, how am I doing on time? I know I might be coming up close here. We still have a bit to get through though.
Good. Miles, we were muted. Sorry, you've got time.
Okay, cool. All right, so Matlacha Pass. Matlacha, of course, is sort of problematic due to its position. The residence time is higher there. It's behind the island, sandwiched in between the island and the mainland. So water tends to sort of stagnate there. And we see quite a bit of exceedances in terms of nitrogen since 2015 through 2021. Phosphorus, we also see a couple of exceedances recently with that uptrend in the 5-year period ending in 2018, that red dot there. And yet chlorophyll again remains quite low, below the threshold. Seagrass acreage decreased between 2014 and 2021, and we see some evidence of an increase in macroalgae abundance. All right, next slide is going to show a couple of red dots there for nitrogen and phosphorus. despite no trends in that specific 2017 to 2021 period, and below the threshold for chlorophyll. All right, we'll move on to Pine Island Sound. So this one's a little bit different. We do have exceedances for nitrogen through much of the, the second half of the 2010s through 2021 with some uptrends there for nitrogen. Phosphorus low, chlorophyll low. But in terms of seagrass, we actually saw an increase between 2014 and 2021. This is the sort of one area where this is what happened. This is interesting. The easiest explanation is that the water clarity is better in Pine Island Sound, and there's just more tidal flushing, right? There's a lot of exchange with the Gulf, so maybe that excess nitrogen sort of gets out faster. So some evidence of recovery of seagrass acreage between 14 and 21, and macroalgae has been pretty stable throughout the period. All right, so nitrogen is high, but as we said, seagrass has increased. Phosphorus is relatively low, chlorophyll is low, and macroalgae appear to be pretty stable most recently. All right, now moving on further south to San Carlos, again, quite high nitrogen between 2015 and 2021. Phosphorus was typically near the threshold most recently with that one uptrend, the period ending 2018. And chlorophyll A has been near or below the threshold with most recently a downward trend between 2017 and 2021. Here, unfortunately, seagrass also took a hit between 2014 and 2021. Macroalgae seems somewhat stable, maybe a slight increase. Next slide, you see, pink dot for elevated nitrogen. Phosphorus was near the threshold, chlorophyll was below the threshold. And finally, we are at Estero Bay. Similar results here. Elevated nitrogen conditions since 2015. Phosphorus below the threshold despite some upward trends. And chlorophyll typically below the threshold. Again, seagrass losses between 2014 and 2021. And macroalgae actually appears to have shown something of a decline in Estero Bay, which could be a good sign. Next slide shows elevated conditions for nitrogen in Estero Bay, low on phosphorus and chlorophyll. All right, so this next slide sort of sums it all up and gives us a table that kind of encapsulates all these results. So here, down the rows, we're looking at the 13 different areas. Across the columns, we're looking at total nitrogen, total phosphorus, chlorophyll, seagrass, and macroalgae. And this is focusing on, the 2017 to 2021 period. Obviously, this is before Ian and Milton and Helene. When we get to doing a sort of update and follow up, those hurricane events are going to feature heavily in the story. But up through 2021, we see, in terms of nitrogen, very elevated conditions throughout the southern areas, tidal Caloosahatchee River through Estero Bay. In the northern areas, Charlotte Harbor proper, Lemon Bay, and the Piece of Mayaca River segments, we see nitrogen concentrations near the threshold in 2021. But remember, in those northern areas, we also saw increases in trends that were quite alarming. And in 2020, in most, if not all cases across those northern segments, the nitrogen concentrations as an annual average were elevated. I can hazard a guess as to what we would see if we extended this, through 2024. Those elevated conditions might sort of persist. I'm guessing, and this is just speculation, that 2021 was sort of an anomalous year with low nitrogen concentrations. I wouldn't expect that, to indicate a sort of reversal of that upward trend, unfortunately. Others in the room may have different opinions. I think that would be an interesting discussion to have. But, the 2021 nitrogen conditions in particular might be a sort of deceivingly optimistic situation for nitrogen. Phosphorus and chlorophyll were remarkably, most often low, as indicated by the green in those columns, with a couple of exceptions for phosphorus in Caloosahatchee and Malachite Pass. And this really emphasizes why it's important to not just judge the condition of the system based on what you can collect in a water sample bottle. Chlorophyll here, which represents phytoplankton or microscopic algae floating around in the water column, doesn't seem to be indicating, the problems with the system, right? I mean, we know that there's a problem because we're losing seagrass, or we've lost seagrass and haven't recovered it yet. What appears to be the more sort of indicative sort of symptom of that problem is the indications we have that macroalgae is proliferating and increasing in many parts of the system. So it seems that all of those increases in nitrogen are translating into macroalgae production more so than phytoplankton production that we measure as chlorophyll. And so this, the point here was to give a more holistic kind of, diagnosis of what's gone on over the last 20 years in the system, and macroalgae is an important part of that story. Another important point here is that Hurricane Irma was definitely a sort of turning point recently. Those seagrass losses occurred after Irma and the big 2018 red tide bloom that immediately followed. However, the nitrogen trend results indicate that elevated nitrogen concentrations were already trending upward, increasing years before Irma hit, right? So we first saw those increases in nitrogen trends in the northern parts of the system. We first saw those occurring starting in like 2012, right? So we've been like sort of ramping up the nitrogen level in the system, and then Hurricane Irma hit, and that sort of suggests that the increased nutrient abundance of nutrients made the system vulnerable to these kind of changes from these from Hurricane Irma and the red tide bloom. So you want to think about the things that we can control, like nutrient pollution, and how much space we're leaving for things that we can't control, like hurricanes and other events. Okay, I think the final slide is up next, and this is just emphasizing some of the differences across different parts of the system. So as I talked about earlier, northern parts of the system tended to show this sort of increase through most of the 2010s in terms of nitrogen concentrations, whereas in the southern parts of the system that are more influenced by the Caloosahatchee, we saw sort of this emergence of this kind of stability of nitrogen concentrations, in many parts still too high, but not increasing. Okay. And why that is exactly, we're not sure. Of course, that's the subject for more research potentially. But of course, we know that the Caloosahatchee River is actively managed, whereas the Peace and Myakka flow more naturally. So that might have at least something to do with differences in how the northern and southern parts of the system sort of behave in terms of nutrient concentrations. But that's also a bit speculative. Let's see, the final point down here: Everglades restoration and watershed restoration in river systems to reduce pollution from wastewater, stormwater, and other sources is critical to lowering nitrogen levels, increasing and restoring seagrass, and decreasing macroalgae abundance, right? So one thing I want to emphasize is, Lake Okeechobee is important, Caloosahatchee River is important, but, the entire system is important too. I published a paper in 2022 linking red tide intensification to Lake Okeechobee. So we found that link there between nutrient inputs from the lake and coastal red tides. That does not exclude other parts of the system from as having an influence as well. And actually, I've got some preliminary research I'm working on right now that links nitrogen inputs from the Peace to coastal red tides in much the same way that I discovered for the Caloosahatchee and the lake. So finding that the answer is yes in one place doesn't say anything about whether the answer is yes or no somewhere else. And generally, my assumption is that it's sort of all of the above. Is it agriculture? Is it septic? Is it wastewater, stormwater? Yeah, probably all of that. And the more interesting question is where exactly are the biggest contributions and influence coming from, and where is it feasible to do something about it? So that's the sort of direction my research is going the last few years. And with that, I believe the last slide has contact information. If you're interested in a copy of the, oh yeah, one more thing. CHNEP put together this sort of fact sheet summarizing the results of the trend analysis study. So if you're interested in that and or the paper, you can reach out to me or Jennifer or Nicole, and we can provide a copy of both of those. And if you have any detailed questions, you can set up a Zoom call, or if we have time, we can do a quick Q&A here. I think my contact info is on the last slide if you want to email me any questions or set up a meeting. All right, that was a whirlwind. Thanks a lot for your time. A little bit over, but maybe we can squeeze in a couple questions.
Yeah, thank you, Miles. And you guys all have this 2-pager with the QR code to the article. Any questions from us?
We'll be real curious to see if hopefully he'll get the funding to be able to update that. Particularly interested in seeing what happens out in the Caloosahatchee. Is the lake's been managed a lot differently since the study was done versus today. So I'd be real curious to see.
Plus the impacts from the hurricanes too, you know, has it changed?
Yeah, I think you all are aware, like, there's always like a lag in getting the data. So I think once we get enough of it, our hope is to do that update again. And we do have some other ideas, that hotspot analysis, you know, is something that Miles or someone similar could do, which helps us kind of go up into the watershed and try to identify, you know, exactly where some of that higher nitrogen loading is coming from. So we see this as kind of one step, as Miles mentioned, in many other analyses that can be done to build our understanding and inform our management of these systems.
Yeah, one nice thing is when we get to update this trend analysis, you know, let's say later this year or next year, the good news is it won't take as long. There won't be as long of a delay because that sort of initial, you know, I mean, having to like curate all the data from, you know, 20 plus years and sort of create the workflow for the trend analysis and everything. That took quite a while, but now, you know, sort of updating should be much quicker. So I would imagine like if we got some of the funding we applied for, you know, maybe we could have an update through 2025 published by the end of next year, you know, something like that. So instead of a 3 or 4 year delay, maybe it's a 1 year delay. I think that could be realistic.
Yeah, that would be great. You know, we get a lot of questions. This is Mindy with the EP. We get a lot of questions about, you know, seagrass restoration and should we be planting these areas that we've lost seagrass, and we're just so unsure, you know, of the water quality and the macroalgae that's there and if it's going to just disappear. So I think having updates and answers are going to be really critical moving forward, trying to restore these areas. Yeah, thank you. Any other last question? Okay, thank you, Miles.
All right, thanks a lot.